Hello, Dr. Su. Good morning. Today, I'll be presenting you a brief review about my project, Vehicle Routing Problem. So, today we'll be seeing what actually the vehicle routing problem is and the methods for solving it and how we get the geographical data and distance matrix and we'll see the visualization of it and finally the summary. So, what actually the vehicle routing problem is? Say, for example, you have a fleet of 100 trucks and you have to drop a delivery plan for 100 trucks and 1000 locations every day. Your plan must be in such a way that it minimizes the cost and at the same time it maximizes the efficiency. So, how do you manage that? This is exactly the question of vehicle routing problem. This is one of the most efficient math problems to solve. When you have to consider multiple constraints like the number of vehicles capacity, time window of stores, types of goods, etc., you solve the vehicle routing problem and you can improve vehicle utilization, which means that you can transport more goods in one go. Consequently, your fleet traveling time will be reduced. So you will save lots of logistic costs. Coming to the real world use cases of VRP, that is the vehicle routing problem. VRP is a common use case for businesses that deal with some kind of transportation, such as food delivery, package delivery, personal transportation, technician scheduling, etc. Coming to the type of VRPs, we have different types of VRPs, like capacitated VRP. A capacitated VRP means the vehicle capacities are limited here and we have to plan accordingly. The next one is multiple depot VRP, where the vehicle fleet is distributed over a number of depots. The next one is split delivery VRP, where the same customer is allowed to be served by different vehicles. And the next one, VRP with time windows, where the customer is only able to accept the delivery in a certain time window. The next one is VRP with pickup and delivery, backhauls, etc. Coming to the solution methods, here basically we have two methods, the exact approach and heuristic approach. The goal of exact approach is to design algorithms that can find the optimal solution most efficiently. They are rarely used for practical applications due to the difficulty of VRP. It takes them unreasonably long to find solution for even moderate sized problems. So they are slow. And examples are branch and bound algorithms. The next one is the heuristic approach. Uh, Heuristic approaches are designed to provide solutions quickly by trading optimality for speed. So while they only produce an approximation of the optimal solution, you get something you can use to solve that problem at hand, and you get it in a reasonably short amount of time. Coming to the meta heuristics, this is an advanced heuristic approach, basically the subset of heuristic approach. And these methods are used for controlling the basic heuristic algorithm with a goal of exploring the search space more efficiently. One of the characteristics is that they are not problem specific. And the examples include simulated annealing, taboo search, and late acceptance. Coming to the implementation of meta heuristics, here we can build an API using a heuristic design in Java and code scoring function as part of the API. Coming to the VRP scoring function, it does not really matter whether we optimize for the fastest or shortest route. In both cases, you have to get the number based on the length and type of route connection between the points in the entire route. To search the solution space efficiently, it has to calculate the score quickly. So this means you should evaluate any IO operations during the score calculation, especially accessing files on the file system or API services over the network. You have to calculate the complete distance matrix for all locations which are part of the problem and keep that matrix in memory while the application is running and determine the final and optimal solution as a final result. OpenStreetMap. There is a project called OpenStreetMap which contains geographical data about the whole world. Data is contributed and maintained by the community and it's open source. This project gives us the travel time between any given 2 points on the map. To extract the exact type of information that we need from OpenStreetMap data, specifically, we need to find route connections between the points of interest and the time it takes to traverse each connection using selected type of vehicle. Then Graphhopper. There is a project called Graphhopper that can be fed with OpenStreetMap data, and it has an API that finds routes between points together with details such as travel time and the exact route geometry, which is useful for visualization and even directions, which is useful for navigation applications. Then for visualization of program and solution, we use leaflet map visualization. It is lightweight, it has a nice API and is very flexible and allows you to consume vaster services from any vendor. Here, we also add an important feature called real-time planning, in which we can provide new information about the problem while the server is running, and it will take that into account and give the best solution according to that. So finally, coming to the summary of the project, the vehicle routing problem is very difficult and it uses the meta heuristics and quick score calculation. And the geographical tools which we'll be using here are the OpenStreetMap for mapping the data, the Graphhopper for route calculation, and Leaflet for the visualization on the web. And this is the brief summary of my project. Hope you like it. Thank you.